Dear engineers, welcome back to my channel. This video is very interesting, so please watch full videos.
Super important questions. BCV302. Engineering Survey. 2. Discuss the evolution of surveying tech. 1. Define engineering surveying and its importance. Classify surveys: control, topographical, construction, cadastral, hydrographic, underground, and their applications. 2. Discuss the evolution of surveying techniques, focusing on chain, compass, and plane table methods. Compare their concepts and limitations to modern methods. 3. Explain the working principles of a laser distance meter, EDM instrument, and distance measuring wheel. Discuss their advantages and limitations. 4. Describe the types of tapes used in surveying, their applications, and common errors associated with their use. 5. Explain how GPS is used in surveying, including its components, signals, and their applications. 6. State the objectives of surveying and classify surveys based on purpose and nature. 7. Discuss the methods, challenges, and safety considerations involved in underground surveys. 8. Compare traditional and modern distance measurement techniques, highlighting the advantages of electronic methods over manual methods. Module 2. Explain the concepts of datum, MSL, and benchmarks, temporary, permanent, and their significance in leveling. Describe theodolite surveying, including setup, horizontal, and vertical angle. Describe theodolite surveying, including setup, horizontal, and vertical angle measurement, and error sources. Discuss the features, parts, and advantages of a total station compared to traditional instruments. Explain how a total station is used to measure angles, distances, slopes, and vertical distances. Discuss the use of a total station for calculating areas and volumes with examples. Explain the process of measuring multiple angles with a total station and its benefits. Compare total station and theodolite methods for measuring angles and setting out points. Define contours, their characteristics, and applications. Discuss contouring methods using a level, theodolite, and total station. Explain the procedure for plotting contours in CAD software and its significance in engineering projects. Define longitudinal and cross sections, their importance, and methods for obtaining them using levels, theodolites, and total stations. Explain the steps for plotting longitudinal and cross sections in CAD software, including common features used. Describe the process of coordinate surveying using a total station, including measuring coordinates, creating job files, and backsite data. Discuss data recording, transfer, refinement, and plotting in CAD. Explain its importance in ensuring accuracy. Explain the types of errors corrected during data refinement after total station data. Explain how to calculate the area of a site using total station coordinate data and its applications in civil engineering. Module 4. Discuss horizontal curves, compound, reverse, transition, combined, and vertical curves, their components, and applications. Explain Rankin's method for setting out horizontal curves using theodolites and total stations. Compare the methods. Describe methods for calculating areas using the trapezoidal and Simpson's rules, and their appropriate applications. Explain volume calculation using prismoidal and trapezoidal formulas. Compare their accuracy and applications. Discuss the process of earthwork volume calculation from spot levels, contour maps, and embankments. Describe the procedure for setting out buildings using the centerline method and other techniques with a total station. How do total stations simplify curve setting and earthwork volume calculations compared to traditional methods? Explain the role of CAD software in plotting areas, volumes, and curves for construction projects. Provide an overview of the GPS system, including space, control, and user segments, and the reference coordinate systems used in GPS. Differentiate between absolute and differential GPS positioning. Discuss the Goggins system in India and its relevance. Explain the types of GPS receivers and their applications in engineering surveying. Describe the process of conducting engineering surveys using differential GPS, including its advantages. Introduce drone surveying, its applications, advantages, and the equipment involved, platforms, DGPS markers, sensors, and software. Explain the steps in drone surveying, from flight planning to post-processing using photogrammetry software. Discuss the types of output maps generated from drone surveys and their integration with CAD software. Explain the applications of remote sensing in GIS and surveying and how they complement traditional techniques. Please subscribe, dear engineers. Your own channel.